So now we're on to chapter 5.5, which is standard form. And we're looking to graph linear equations using intercepts and write linear equations in standard form. So this is our third different form, right? We've had slope-intercept form, point-slope form, and now we're in standard form. And the whole reason behind these different forms is because some of them are better than others in different situations and for different things. And the one thing that standard form is very good for is finding intercepts of a line. And what we're talking about is the x and the y intercept. So obviously the x-intercept is where a line will cross the x-axis. Okay, so if we had an x and y-axis, the x-intercept would be where it crosses this line, and the y-intercept would be where it crosses this line. And standard form is very good for that. So from this screen or from this slide, we would like you to make sure that you copy this down. Standard form of an equation. Make sure that you know that a, b, and c are real numbers, and a and b are not zero. Not both zero, sorry. So what are the x and y intercepts of the graph? So how do you do this? The way that you do this is basically eliminate the one that you're not looking for. So if we want to find our x-intercept, we would plug in 0 for y. So we'd have 3x plus 4 times 0 equals 24. When we do that, 4 times 0 is 0, so we're left with 3x equals 24. Divide both sides by 3, and here you get x is 8. So our x-intercept is 8, and our y-intercept is when you plug in 0 for x. And when you do that, you get 4y equals 24. Oops, divide by 4, y equals 6. So your y-intercept is 6. That's simple. So I'm going to try one of these. So again, we just take and we plug in 0 for y. So we get 5x equals 60. Divide both sides by 5, and you get x is 12. Then take and do the same for the other. So 5 times 0 minus 6y equals 60. We get negative 6y equals 60, and therefore y equals negative 10. So that is how we have our x and y intercepts. But now what this is asking for you to do is graph each equation. So we're going to have to graph each one. So what we're looking for is, if this is our x-intercept, that means that is where it crosses the x-axis. So we're looking at approximately 12, which is out here, and our y-intercept of negative 10, which is approximately down here. And now you have 2 points. And remember, 2 points is all you need in order to graph a line. And there is the line that this equation represents. What is the graph of x minus 2y equals negative 2? So again, plug in, and you can do this in any order. X equals negative 2, so that one was easy enough. And then if we plug in 0 for x, divide by negative 2, so negative 2 divided by negative 2 is a positive 1. So our x-intercept is negative 2, which is right there. Our y-intercept is 1, and therefore there is the graph of our line. Now, what happens when you are left with equations that just have an x or just have a y? So if you think back, we covered this in our first couple of chapters when we made our little t-charts. So what happens when x equals 3? That means x equals 3 all the time. Okay? So you can pick absolutely any point on y, or let y represent any coordinate, and x will be 3. So if you say, well, Y is 0. Okay, x is 3. Y is 3. X is 3. Y is 10. X is 3. Y is negative 4. X is 3. X is 3 no matter what. And therefore what that means is x equals 3 is a vertical line. Okay, so this is part A. And the exact same thing is true except it's with the y-axis. When y equals a number, it's just a horizontal line on 3. So this is line B. All right. We'll do the first, we'll do part B and C here. So remember x, negative 1, whenever it's x, that's a vertical line. So you just make sure that the line goes through x at negative 1. And here y is 0. You make sure you go through y at 0. So this is actually a line that is right on the x-axis. So this is line B, and this is line C. We're not going to do those. And that is what standard form is all about.